Good afternoon, everyone. Thank you for joining us. My name is Claire. I'm a contract librarian on assignment here with NOAA Central Library. This seminar series is offered through the NOAA Central Library Seminar Program, which provides an educational forum for the presentation of ideas, research updates, and news in support of NOAA's mission. Before we start, I have a few technical tips for attendees. Just so you are aware, you are muted and you are not able to unmute. However, if you have a question, you can type it into the questions panel, and we'll get to those during the Q&A session at the end of the presentation. If you're having any audio or visual issues, if you can't hear the speaker or see the slides, please try logging off and logging back on, and that will solve most issues in GoToWebinar. Just as a reminder, this is being recorded. If you would like to revisit this seminar or view previous seminars, you can find them on our YouTube channel. Now I'm going to turn it over to Peg, who's going to introduce our speaker today.
Thank you so much, Claire. Greetings, everyone. This is Peg Brady from NOAA Fisheries. Welcome to the 2022 EBM seminar series. This series continues on from, we started this back in November 2017. Our main objective is to increase awareness regarding ecosystem-based management and ecosystem-based fisheries management specifically, and highlight the progress that NOAA and our partners are undertaking to implement EBM. NOAA Library, Claire and Katie continue to be our great supporters, our co-hosts for this series since the beginning. And the seminars are held the second Wednesday of each month between 3 and 4 Eastern Time. Each presentation, as Claire indicated, is publicly accessible and recorded and archived. So take a look at our past recordings if you haven't done so already. Following today's presentation, there's an opportunity to ask questions and also follow up with our speaker today. And we're very lucky today to have Andy Lipsky from our Northeast Fisheries Science Center, who'll be focusing in on fisheries, wildlife, and ecosystem science in the new era of offshore wind development. So thank you so much, Andy, and I see you have a number of co-authors on this presentation, so thanks to them for their contributions. And stay tuned for our next presentation, which will be April 13th. And again, it'll be colleagues of Andy from the Northeast Fisheries Science Center, John Walden and Garrett Piper, an ecosystem quantity index for the Northeast region. So that's April 13th at the same time. So thanks, Andy, and I'll turn it over to you.
Thank you, Peg. Can you hear me?
Yes, very well. Thank you.
Excellent. Thank you, Peg and Claire, for setting this up. And good afternoon, everyone. If it's afternoon in your neck of the woods, I know there's folks joining us from all over. If not, enjoying your tea or coffee at 3 p.m. time from Eastern time zone where I'm presenting. Thank you for the opportunity to talk to you all today about offshore wind development. Let me see if I can advance my slide. There we go. What I'm going to talk to you all about today is setting the context for where we are in offshore wind development, both globally, nationally, and then in the Northeast. So my presentation around fisheries, wildlife, and ecosystem science is taking a Northeast US perspective, where we are sort of ground zero for some of the initial development of offshore wind in the United States. So I'll be setting the context. We'll be give you a whirlwind tour of what's happening in the world of this new industry. And then the bulk of my presentation will talk about the different types of interactions between offshore wind energy development and NOAA trust resources from a Northeast perspective. So these interactions really are probably national in scope, but we'll be talking about them from the standpoint of Northeast resources, Northeast region of the United States. And then I'll finish my talk with some slides, and hopefully we can have a discussion, because I will not use the full hour of our time together. We can discuss, and I'll present on some of the challenges and opportunities of addressing our science and management needs, particularly around our ability to implement ecosystem-based management and ecosystem-based fisheries management approaches. So, and you know, what our aim is in this new era of offshore wind development is we want offshore wind energy, and we want sustainable fisheries, and we want wildlife conservation. Those are our three aims. We also want ocean science to support sustainable development. And as Peg in this whole series embodies, we want to be able to move towards and utilize ecosystem-based management approaches. where we use integrated management that considers the full array of interactions, both at the ecosystem level that includes humans and not sector by sector, species by species, or ecosystem service by service. So those are sort of our three aims globally as we try to address the sustainable development of offshore wind energy. And we'll talk about the end of my presentation, where are we at in addressing these aims. So in terms of setting the context for offshore wind growth in the US, offshore wind energy is taking off, not just in the United States where it's relatively new, but also in European waters as well, where offshore wind energy has been in the waters of the North Sea for well over 20, 25 years. But in terms of reaching our pathways for net zero emissions by 2050, the anticipated development of offshore wind growth is significant. We're looking at 35 gigawatts of capacity today in 2020 and globally to hit and maintain this pathway of 1.5 degrees Celsius. We're looking at 2,000 gigawatts of new offshore wind energy. So we're looking at a major increase both between now and 2030 and a major increase between 2030 and 2050. In terms of national targets, we are, to see this exponential expansion across the US. We can see North America, where we have 29 megawatt. We have 12 megawatts in the waters today with a goal of 30 megawatts by 2030 and a pathway for 110 gigawatts by 2050. In applying some of the 1.5 degrees Celsius pathway goals, the green in these charts indicate how much is likely necessary to address if we are to utilize offshore wind energy to put us on a climate mitigation pathway. So you can see where we are in North America. We're braced for a massive increase in this new use in our waters. Europe already has quite a bit, but they're also going to see a very considerable increase in the scope, scale, and magnitude of development. Same as in Asia, and we have targets both in North America, Europe, and also Asia, and also forecasts for Latin America, Africa, and Pacific. So globally, we are going to see an expansion of offshore wind energy. If we look country by country, you can see where different countries are in this slide. Like I said before, the first offshore wind farm was in the North Sea in Benthic, Denmark in 1991. That wind park is actually already decommissioned. And the industry, as these charts show, are seeing a massive phase of rapid growth. So what is the outlook in the United States? I think I mentioned earlier, we have set targets for 30 gigawatts of offshore wind by the year 2030 and a pathway for 110 gigawatts by 2050. And it's hard to keep my maps and my presentations up to date because these are changing so fast right now with the planning efforts that are occurring across the East Coast, the West Coast, and the Gulf of Mexico. But this just gives you a smattering of idea in terms of some of the areas that are being considered for offshore wind energy development in the Northeast, the Pacific coast of the Western United States, and also in the Gulf of Mexico. In the Northeast, we drill down further where the bulk of my presentation will focus. We have a considerable amount of offshore wind leases already being developed that are already in their permitting and regulatory phases. We have brand new leases that were just announced just back in the end of February, where we set by any type of energy records for a lease auction, and that was the lease areas for New York Bight, which generated $4.37 billion to the U.S. Treasury. So if you were thinking that offshore wind was something potentially small, we had 5 turbines out on Block Island. We have some development beginning in southern New England. I think this lease auction really represents the potential and the real interest in the development of Northeast Shelf ecosystem. So the graph that I have below shows the cumulative footprint of what all this development looks like over time to reach the 2030. So this is just development in the pipeline to reach 2030. We're talking about almost 2.4 million acres of the Northeast Continental Shelf in leases. We're looking at about 10,000 miles of submarine cable to connect leases to their offload ports and offload centers. And we're looking at about 3,400 foundations, individual turbines occupying these areas. We also have an additional 5 million acres that are being evaluated. These areas will be winnowed down to smaller areas, but we have about another 5 million acres that are being evaluated as planning areas that would potentially be new lease areas in the future. So this new use is here, and how do we sustainably develop this new use? Before we get into that, we're going to talk about what does this look like in terms of the actual infrastructure. Well, we have the wind turbines themselves. The turbines are connected through inter-array cables. And then the wind array or wind farms, wind parks are connected to an offshore substation. And there'll be submarine cables that connect from the turbines to the substation. And then there'll be an export cable from the wind energy generation area across the shelf and connecting into an onshore substation. It'll cross the shoreline and plug into the electrical grid. So this is a very simple schematic of what's entailed in terms of an offshore wind development project. In terms of like other energy technologies, it's hard to keep up with the pace of innovation and change. The size of these turbines are growing by leaps and bounds. I think in this turbine generator graph, it ends at 8 megawatts, so it's already well out of date. You know, it ends at an 8 megawatt nacelle turbine generator. We're now looking at 15 megawatt turbines being proposed in some of the lease areas off of southern New England. So the bottom line is turbines and technology is changing, and the potential impacts of these different infrastructure will also change. And we need to be able to grow and adapt our knowledge base with these changing technologies. There's also different types of structures depending on engineering constraints. There are fixed offshore wind technologies, so these are monopiles or jackets, which can be deployed in shallower waters, less than 60 meters. And this is largely what we see in commercial scale production currently. The other form of offshore wind turbine structures are floating turbine structures. And these structures are not limited by depth. So these structures are essentially floated and tied down to the bottom of the sea floor and can be deployed well beyond 60 meters and well to very large depths, depending on the technology. There are no commercial scale floating wind turbine developments yet in production, but there are many that are in current development phases, and there are many pilot scale offshore wind, floating offshore wind projects, such as the project off of Scotland. This is just an example of a project under construction that was close to my home state when I lived there in Rhode Island, the Block Island Wind Farm. This is a 5-turbine construction with jacket foundations. It's a 30 megawatt facility. It started operation in 2016, and you can see these are 6 megawatt facilities. We're now looking at 15 megawatt generators. So the technologies has changed quite a bit over the last decade. Main research array is an example of a floating wind technology that would be deployed in waters in the Gulf of Maine, and there's a large scale effort led by the state of Maine to develop a 16 square mile area off of the Gulf of Maine to deploy as part of a research array floating wind turbine technologies. In terms of the phases of construction, there's basically 4 phases. There's the survey phase, basically understanding the seafloor and understanding the engineering constraints before anything is constructed. And there are interactions with the geophysical and geotechnical surveys, with the increased amount of vessels that are going into these areas. And so there's a survey phase, and then there's a construction phase, which in the survey phase is usually a few years, a couple of years. Then there's a construction phase where construction of the projects takes place. And this, depending on the size of the project, this is again probably another 2 to 3 year endeavor. Again, in the United States, we do not have commercial scale projects. We have the first project, Vineyard Wind 1, that is now beginning construction. We have the Coastal Virginia project, which is a demonstration project in Block Island. And then we have, the operational span of these wind development areas. And the operational span is going to be for 30 to 50 years of production. I don't know the exact year for the new leases, but generally the shelf life for these projects are about 30 years, potentially more. And then the last phase is decommissioning. So when we think about interactions of this development on NOAA Trust resources, we think about our interactions across those 4 phases of development. And offshore wind interacts with NOAA and NOAA Fisheries really across every part of our portfolio, from our responsibilities in the Marine Mammal Protection Act and the Endangered Species Act, to our essential fish habitat provisions under Magnuson, and to the stocks and managed fisheries that we carry out our authorities in managing under the Magnuson-Stevens Act. And the development will interact with the fishing communities that are composed across the entire seaboard, 177 defined fishing communities across 12 states in the Northeast. And offshore wind will interact with our survey operations. We'll have interactions with existing commercial and recreational fishing, and we'll have interactions with important stocks that we manage. So basically, this slide is to show you that everything that NOAA Fisheries does is touched upon by offshore wind development. In terms of just a brief slide, what is our role in the process? Well, the Bureau of Ocean Energy Management is the lead federal agency and the primary decision maker for offshore wind energy development. NOAA Fisheries, or NIMS, provides advice to BOEM. And our advice is really limited to our statutory mandates under the National Environmental Policy Act and the Magnuson-Stevens Act, where we give advice and comments, or through incidental take authorizations through the Marine Mammal Protection Act and biological opinions through an Endangered Species Act. NIMS advice and recommendations and comments are received by BOEM for the decision making on these projects. And we try to ensure that fisheries, marine mammals, endangered species, and ecosystem science expertise is applied to each of the phases of the regulatory process. In terms of what our needs are across our trust resource responsibilities, it's really 4 major areas. We're providing support to the regulatory process through providing data, providing advice and review. We are trying to understand the impacts of development on the marine ecosystem through research and monitoring. And we need to also address the impacts of wind development, which I'll go into further, on our scientific survey enterprise. As I said before, the offshore wind development is going to change uses of the ocean where there are existing uses. And the use of the ocean for scientific monitoring research is also a potential space use conflict with this new form of development. And the 4th area is identifying pathways and making recommendations to mitigate the impacts, to promote ocean co-use and protect marine biodiversity. So understanding the impacts of offshore wind development on marine ecosystem really occurs in 3 dimensions. It's the social dimensions, in the benefits, the ecosystem services we obtain and we request from our marine environment, the biological system, so the animals and plants that occupy space in the ecosystem, and then the physical and chemical properties of the marine ecosystem. And all of these elements are interact. They're not fixed or stationary, and they're highly dynamic, where one piece of this dimension affects the other piece of the dimension. That's an important thing to consider. So in terms of offshore wind development and in fisheries, for instance, there are some challenges, or some significant challenges in some cases, where we have overlaps or intersections between high-value commercial fisheries and proposed areas for offshore wind development. This is actually a 2015-2016 map. It is now out of date. Some of the areas, this depicts scallop fisheries in the New York Bight area. Some of these areas are now leased. Not all of the areas depicted here are part of the lease areas, but demonstrates that we have some space use overlaps between looking to develop offshore renewable energy and looking to maintain and continue to harvest valuable seafood. And another example of some of the spatial overlays of potential offshore wind development planning areas in red outline, and then where we have existing leases. And this does not include all fishing activities. It just includes all fishing activities that we have vessel monitoring system data for, and from the years 2012 to 2016. Some of the other challenges of offshore wind and our trust resources is looking at the overlap between our important marine mammal species like North Atlantic right whales in offshore wind energy in southern New England, particularly around Nantucket Shoals, where we have identified really the only winter foraging habitat on Earth for North Atlantic right whales, which co-occurs with the southern New England wind energy areas. And you can see some of our survey track lines. That's what's shown on this map. And all this data, actually, if you wanted to see it, you can go to whalemap.org and actually get historic data on marine mammal sightings, including right whales, as well as overlays of wind energy development areas and these observations. A really good source of information, I'll go into sort of a brief summary of these interactions of wind development on the marine ecosystem, was a publication in the Journal of Oceanography that was published by myself and a whole bunch of other really smart scientists that brought together European and North American experts to tackle what do we know, what do we need to know about the effects of offshore wind development on fisheries. And I'm just going to highlight some of the key lessons that came out of that series, but I encourage all of you, if you want, looking for a good reference on these interactions, to go to the O series. So understanding the impacts of wind energy development fisheries, we looked at it from socioeconomic effects. Setting the context is a particular chapter. The impacts of sound, electromagnetic fields, the artificial reef effects of altered hydrodynamics. In terms of socioeconomic effects, the interactions of offshore wind development that have been documented with, particularly around commercial and recreational fisheries, include the following, not limited to this list, but just a smattering. The potential exclusion or preclusion, I would say, that these areas are not going to be formally, you will not formally be prevented from operating in these areas, but many of the fisheries that operate in these areas believe that they will not be able to operationally and safely fish in these areas. So there will be displacement of fishing effort. There will be impacts to navigation, particularly around radar interference. And I highlight the recent National Academies of Science report on wind generator impacts on marine vessel radar, which is a issue that will affect navigation once you're inside these areas and trying to navigate. There'll be impacts on habitat and target fish species. Not all these impacts on habitat may be negative. Some of them might not. Some of them might be positive. But if they do change, it could potentially change the way we target these stocks and the ability to access those stocks. There's issues of marine safety and operations in these areas, particularly when operating during foul weather, and potential for gear or vessel damage, whether it's through collision, elision, or hanging up on submerged cables that potentially are not buried or have been supported with concrete mattresses where they can't reach burial depths of approximately 6 to 10 feet, and then potential fishing restrictions, potential changes in fishing methods, and then obviously the multiplier effects that ripple through coastal businesses. If fisheries operations are affected, it can affect the seafood supply chain and everything that goes with it. So those are some of the socioeconomic impacts that we are concerned about. Sound is also another important element, and sound occurs throughout the life of the projects, whether it's from the survey to decommissioning. What we know about sound is fairly limited for most fish species, populations, and life stages. We know very little on shellfish. We have a lot of information and understanding of sound impacts on marine mammals, so we can draw from that experience, but on fisheries, there is limited information. And new understanding needs to be integrated into our assessments, and particularly around cumulative impact analyses. Electromagnetic fields from the submerged cables have the potential to interact with our resources, potential for behavior change in finfish and particularly shellfish, particularly electrosensory species like elasmobranchs that can be particularly vulnerable to changes caused by EMF. A lot more research is needed to understand not just what happens to individual behavior, but what happens to population level effects. In terms of the other fairly well documented effect of offshore wind development is we're essentially creating these new islands in areas where there are none. And so when we put structure in the ocean, we create places for organisms that like structure to attach to. And so we start to form artificial reefs. So we are altering habitat, which can support a diverse and abundant artificial reef community. The population can be affected by these changes in availability of food, shelter, predators. However, most of our understanding of artificial reef effects on wind turbines are really at the turbine level. We're only recently starting to see research that scales up our understanding of how does the individual turbines at a larger scale affect or impact a population. Again, a lot more understanding needs to happen on artificial reef effects. And we can also draw from artificial reef literature from other sources of development, whether it's oil and gas development or the actual habitat creation literature for creating artificial reefs. One of the large area of uncertainty are the altered hydrodynamic effects. And this picture on the right shows wind wakes from turbines in the North Sea. And basically, by the placement of the turbine footings, as well as the harvesting of kinetic energy, which we're taking kinetic energy from the system, it can alter local and regional aerodynamics and hydrodynamics, which can change turbulence, mixing, and vertical stratification. It can also lead to sediment resuspension and sedimentation, temperature and salinity change, nutrient transport and exchange. The scale of development is related to the magnitude of this effect. And some of these wind wakes can be detected as many as dozens of kilometers from an individual turbine. So these are more far-reaching effects that we need to consider, particularly around the changes in oceanography and the organisms that depend on that oceanography. We did a summary of the offshore wind effects on the Northeast U.S. shelf ecosystem in this series. We cataloged and documented that our fisheries surveys and assessments will be impacted. We'll get into that very shortly. Our fisheries resources will be impacted, both positive, negative, and maybe not at all, depending on the species or the habitat through the introduction of sound, electromagnetic fields, artificial reefs, and changes in hydrodynamics. And fishing activities and societal benefits will also be changed by the alteration into offshore wind development. Some of the lessons learned from Block Island, we saw that has occurred through monitoring. We've seen a lot of mussel aggregations that have been established within the footprint of the turbines in different biotypes, new biotypes forming within about 100 meters of the turbines. And that's really one of the lessons learned from the monitoring is most of these changes that have been documented at the turbine scale happen very close in proximity to the turbines themselves. Wildlife conservation has similar impact producing effects, from sound, habitat alteration, displaced fishing effort, aggregation effects or changes in oceanography, potential increases in vessel strike risk, and EMF. And it's important to understand these impacts on wildlife, particularly species that are legally protected like North Atlantic right whales. And the need to collect data on species and their habitat and food webs is really critical. What we need to move to is monitoring and understanding to be able to incorporate this understanding at the population level. This is just an example of some of the increasing use over time from Nantucket shoals and the southern New England wind energy area by the highly endangered North Atlantic right whale. The other impact interaction we have with our trust resources is actually our surveys themselves. In the Northeast region, we have 13 core surveys that range from our protected species surveys used, such as our North Atlantic right whale aerial and vessel surveys, to our fisheries independent surveys, like our spring and fall bottom trawl survey, to our shelf break ecosystem surveys, like our ecosystem monitoring surveys. This data is critical for a number of reasons. Many of these data sources date back to the early 60s, and when you add them up all together, you almost are looking at about 4 centuries of total survey effort collected by NOAA Fisheries. The data that these time series represent use various types of survey designs, from stratified random to fixed station, and they have major applications for understanding population abundance, distribution, and health. They also underpin our fisheries, valued at $27 billion a year in commercial and $6.5 billion recreationally. This is an example of an overlay of offshore wind development leases and planning areas with our scallop survey strata. These are the individual areas of our survey that are sampled, and our bottom trawl, spring and fall bottom trawl surveys strata. You can see that this new type of habitat, per se, new type of use, has just the footprint of the use, not necessarily the footprint of effects of the use, has a significant interaction with the areas that we're currently surveying. So wind energy actuates impacts on these surveys basically in 4 ways. Preclusion, like I mentioned earlier, because our large vessels are not going to, like the Henry Bigelow, are not going to be safely able to go into these areas and sample and deploy mobile gear or otherwise. And also the height of these increasingly large turbines will intersect with the height that we normally fly our aircraft at to conduct aerial wildlife surveys. So they will be precluding our survey operations. We may also be impacting the statistical design of these surveys. Many of these surveys are stratified random sampling, and the probabilistic survey design model would be problematic to be employed the way it has been once we install wind turbines and submarine cables in these areas. The other impact is habitat change. So these areas, as I mentioned, may affect the distribution, abundance, and vital rates of populations that we are managing inside the area of effects. And the variance structure may be different outside these areas. And understanding those differences in variance structure is key so that we don't introduce bias into our estimates of abundance. And the other thing is impacts to our sampling. So traveling outside and around these vast areas that will be occupied wind turbines can reduce our ability to sample areas in totality because of increased vessel transit. Or in terms of aircraft, when we have low cloud cover, that low cloud cover could occur at a elevation where the turbine maximum blade tips occur, in which case we won't be able to fly higher in those locations because of cloud cover. So we'll have to fly during different times. The implications of these effects are impacts on the American public that are looking to have local sustainable seafood in the fishing communities that depend on seafood, and also expect the recovery and conservation of endangered species and marine mammals. Our commercial and recreational fishermen and fishing communities, we can potentially increase the uncertainty in our estimates of abundance if we're unable to obtain the data or these time series are broken. Through the application of the precautionary approach, this could impact the setting of quotas to employ more conservative measures. This also could be more conservative management strategies employed into commercial fishing operations associated with protected species management. As I said before, for protected species, we could have greater uncertainty in terms of understanding organisms like the North Atlantic right whale and being able to employ accurate and effective assessment and recovery programs. Non-fishery sectors would also be impacted by impacts on our scientific operations because we use this information for a variety of other ocean users like shipping and other forms of energy. Other federal agencies that depend on our science could also be impacted through the need of incidental take statements or ESA biological opinions that depend on having timely and accurate and the best possible science to make management decisions. And finally, climate science, disruptions of our 60+ time series decreases our ability to understand and mitigate the effects of climate change. So there are potential interactions, space use interactions. Doesn't mean that we can't address them. And that's what we're going to talk about in my last few slides. So applying integrated ecosystem assessment approaches to inform leasing and planning, to utilizing innovation in new sampling methods like eDNA or optical remote systems, or our next generation stock assessment enterprise that leverage ecosystem understanding, innovation, and timely and efficient data are all challenges to deploy, but opportunities to address these challenges. One of the things that we are looking to address the challenge of our scientific survey operations is sort of a 6-point plan to address those impacts across our fisheries and protected species surveys. Evaluating our survey designs, figuring out will a certain survey be impacted in the stocks that depend on that advice be impacted by changes in the impacts to our surveys, identifying new approaches, both statistical approaches and platforms and methods, and then determining adaptation strategies for each of these surveys. And once we've done that, then we need to calibrate new survey approaches with old ones. And at the same time, we can do a lot more with some existing data to bridge the gap in data quality and availability. And then finally, the second to last stage is implementing wind energy monitoring to fill these scientific survey data needs for the 30-year lifespan of these projects. And the 6th element is to, as we move through these 5 elements, we'll be developing and communicating new regional data systems. We don't make these changes in a vacuum. Fisheries and protected species management is a participatory process, and we'll be needing to work, and we'll want to work with all our partners to come up with these solutions, and also to develop the data management systems to deliver new forms of data. Where are we at in implementing a survey mitigation program? So this is one of our challenges, is that the exponential growth of this industry is happening fairly quickly, and we need to be able to move very quickly to address the 6-point plans for survey mitigation. And so we've only really just started looking at this in terms of three of our surveys, our fall and spring bottom trawl survey, our scallop survey, and we have some initial work at calibrating flight aerial surveys for right whales at higher elevations. But we have a lot of red in this chart, so there's a lot of work to do. One of the projects that we have underway right now, I'm going to just looking at my time, just be very brief, is conducting a survey simulation experiment, so that we have already begun working with the Bureau of Ocean Energy Management and held stakeholder workshops to create a simulation experiment for our multi-species bottom trawl survey to really look at and dig into the issues associated with wind development on the 40 stocks that require advice from that survey. Other opportunities is implementing passive acoustic monitoring across developments. We've had some great success developing guidelines, working with agencies and also the wind industry and our academic partners, creating and building repository and website for PAM data. And this is going to be really critical for us to understand the movement and location of animals both during construction and after construction for monitoring. Another opportunity is to better understand the human dimensions, and that's a major gap in our understanding. is working with our international community through the International Council for the Exploration of the Sea, where we held a workshop attended by 50 experts from 9 countries looking at the multidimensional issue of fisheries interactions with offshore wind, both from the social standpoint, the economic standpoint, and the environmental change standpoint, which allows us to build models or conceptual models of economics, environment, and culture related to the changes in fishing operations. Again, this is very recent work, and there's a lot more work that needs to be done. Other opportunities is work we are currently conducting with the Department of Energy and Sea Grant to invest in some of these human dimensions research. And so there was a call for proposals last year, and hopefully pretty soon when we get a federal budget, we'll be able to announce some investments in some of this human dimensions research. We've developed tools for communities, developers, states, and Bureau of Ocean Energy Management to see the exposure of fisheries operations across these development areas and make some of this confidential information available so it can be used by removing sterilizing it so it can be shared. And we're also working to develop predictive displacement models for Atlantic sea scallop fisheries, so we can model where these fisheries that may be displaced, where will they go, and how that can be incorporated into our review of these projects and inform mitigation planning. Regional collaborations are a major opportunity. We have opportunities working with the fishing industry through the Responsible Offshore Development Alliance. We have the Bureau of Ocean Energy Management and NOAA and BOEM have been working on a Synthesis of the Science. We held a workshop and a white paper that will soon be released. We have an upcoming workshop working with Rhoda on a floating wind technology workshop and other materials for floating wind technology. We've worked to develop guidelines for research and monitoring with the Responsible Offshore Science Alliance and helping to support a recently stood up regional wildlife science entity. I've already mentioned the Sea Grant research funding opportunity, the work we're doing under ICES with the new fisheries and offshore wind working group, and we have an upcoming strategy on survey mitigation working with the Bureau of Ocean Energy Management. Hopefully in the next few weeks, we'll see a strategy document released for public input. So addressing this challenge of wind energy development on marine ecosystems is, we need to consider the non-stationarity of the system, both the social, biological, and physical. We need to make sure the ocean science is available to support the sustainable development, so the impacts on our scientific enterprise are understood and addressed. And we need to move towards ecosystem-based management because we're talking about multiple uses: conservation, energy, and seafood productivity, tourism, all these uses that are part of considering the interactions of the marine ecosystem with offshore wind energy it's very difficult to silo any one of them and achieve sustainability. And that is a challenge, but it's also an opportunity. We need to be able to apply tools that we have now, like integrated ecosystem assessments, and make sure that these tools are utilized at the right stage of the development process so that we can look at and be aware of the trade-offs that may be occurring, identify the trade-offs and mechanisms to mitigate those impacts. And we can utilize IEAs and management strategy evaluations, such as the survey simulation modeling effort that I described earlier. So we need to do a lot more. We are utilizing these tools, but if there's any new use that's before us right now that has thrust us into needing to implement EBM and EBFM, climate change and addressing climate change through offshore wind development is that impetus. We need to move there very fast and very quick. The renewable energy process, this is my last slide, is a linear process. And the question that I don't have an answer to this question, but the question that we're all faced with is how do we implement EBM and EBFM to address all of these various interactions around wildlife, fisheries, and offshore wind energy, and do it in a way that can inform the different phases of the development life cycle. With that, I thank you for your time, and I'm open to any questions.
Thanks. So attendees, you can enter questions into the questions panel. We do have some time here for those. Any questions that we don't get to will be emailed to the presenter after the seminar. So go ahead and send your questions in. We'll get to as many as we can here. The first question for you today is, are there any indications if fishery stocks may increase with the amount of artificial reefs created from these new structures and scour protection that will be put in place?
So when you look at the, can you hear me? I think I paused my presentation. I just want to make sure I didn't pause.
Yes, we can hear you.
Excellent. The literature, when you look at the literature on artificial reefs, there's a vast literature. And if you assume that turbines are, they're a little bit different than the enhancement projects to date, because except for the ones that have created sort of islands that have gone up into the air column. There are much smarter people than me that can answer this question, but the bottom line, where we've been able to tackle that question of increase, attraction production hypothesis. Are we just attracting animals by creating structure, or are we actually achieving productivity? In some cases, we are able to achieve productivity. But when you look at some of the meta-analysis that's been conducted on artificial reefs, there are key things that need to happen in order to achieve that. One of them is that you need to design the reef structures to actually do that. So they need to be designed with a particular management objective. It might be a potential life history stage of an animal, for instance, and it needs to be large enough to have an impact on that species. And so where we've had success seeing increases in productivity, it's where we've designed these artificial reefs to do just that. We're not placing offshore wind farms to increase net fishery productivity. That has not been part of the planning process. It does beg the question, though, could we be applying EBFM and EBM to our planning efforts? For instance, would there be places where we could increase productivity? The North Sea, we have seen, we have seen a positive effects on some species that enjoy the additional structure, but we have not seen the type of studies up until really recently where we could say that the effects of turbines are having a population effect, because those studies have not been done.
Okay, the next question is, what limits operations to 30 to 50 years?
So we're getting into expertise that I don't have, because NOAA Fisheries is not the lead agency. And so it really depends on the lease term. I think these leases are for 30 years of operation. The infrastructure themselves with maintenance can achieve 30 plus years of operation. So that what determines the amount of time that they're in the water would be the terms and conditions in the lease stipulations that are part of the agreements between the Department of Interior's BOEM and the developers. I'm sorry, I can't give you a better answer to that.
Thanks. The next question is, can you be more specific about opportunities for industry to collaborate on solutions? Specifically, I'm wondering if NOAA is considering substantially expanding industry-based surveys to supplement/replace Bigelow in areas where it can no longer operate due to wind.
Yeah, so the survey simulation experiment, I didn't spend much time on. We'll be examining a number of scenarios for how do we address the loss of Bigelow access into these areas. And so we're at the really beginning stage of that modeling effort. We had expert workshops with academics, assessment scientists, and also including expert members of the fishing industry who are our partners in fisheries science and management. We are looking at utilizing smaller vessels and industry platforms for carrying out these types of surveys. So there are opportunities for us to explore that. The largest hurdle right now is that we don't, and I showed you that table of where are we in implementing these programs. for survey mitigation. And there was a lot of red on that chart, and that has a lot to do with the fact that this is a new use. We're ramping it up very quickly, and we're trying very hard to secure the additional resources to do so. The president's budget, fortunately, included substantial increase in funding for NOAA Fisheries to develop and execute some survey mitigation elements. Not everything we needed, but a good starting place. And we would be working with the fishing industry and our industry partners to develop these solutions and opportunities. But we are currently resource limited. Right now, we have an agreement with the Bureau of Ocean Energy Management on that bottom trawl survey effort. We have some soft money that's supporting some of the aerial survey calibration work. But other than that, in order for us to really engage and move to these new surveys, we would have to stop doing other things based on our budget restrictions. So we'll see when we get a federal budget. We're hopeful that we'll be able to do this and partner, because that is part of our goal.
Okay, so the next question here, this is a multi-part question, so I am going to send it to you in the chat so you can read it as well. The question is, do you think there are any aids/obstacles unique to wind energy on the US West Coast and windy Alaska? Do you envision the same wave of interest out west, and when?
So playing crystal, well, the first part of the question, I think a lot of the interactions are very similar. Most of the development on the West Coast will be, as I understand it, will all be floating technology. And there's a lot of uncertainty because we don't have commercial scale floating technology anywhere on the planet yet, but that's soon to change. So I think that the bins of interactions are likely all the same, but the interactions will be different because of the technology that is utilized. The floating wind turbine arrays, the turbines themselves that are floating will be connected with with submerged cable that will move through, that will be in the water column itself. Some of it will get buried, but depending on depth, much of it won't. So what I understand from some of the initial planning in the West Coast is we could probably foresee more significant preclusion of fishery operations, particularly mobile gear in floating wind energy areas in the West Coast. We also have floating wind energy proposed for the East Coast, as I mentioned as well. So we will have some similarities to draw from. I can't answer the crystal ball part. Do I envision the same wave of interest out west and when? I will say I've been working in offshore wind energy for quite some time. I worked on the first project, Block Island Wind, and I worked directly with the developer on that project to address some of the fisheries interactions and spent a lot of time with them. I don't, my conversations with them on what they saw that, I won't name names, but did they foresee the industry looking like it would look now? I don't think they would say, they would think of how large and fast this industry is growing. It's really amazing, the amount of change over a short period of time. So I don't believe I have the expertise. I think the $4.35 billion lease sale, which doesn't guarantee you get to build anything, it just guarantees you get to write a 150 or 200 page report, site assessment plan report, tells you something that there is interest in in offshore wind development, particularly in the Northeast.
Thanks. The next question is, what stages in the permitting process can NOAA be involved in if they're not already?
So NOAA Fisheries, and I'm speaking, I had that one obligatory slide in there about our role in the process. And so I'm on the nerdy scientist part of the side of the house for NOAA Fisheries, and we have another side of the house that's our regulatory and policy expertise, like our Greater Atlantic Regional Office and our Office of Protected Resources that issues the incidental take authorizations. And they really lead our regulatory consultations and work directly hand in hand with BOEM, but they also work very directly with the Science Center and we help provide review. My understanding is that we are involved development timeline from before there's a lease, when we're starting to think about planning areas. NOAA Fisheries is consulted with a Bureau of Ocean Energy Management. So we are involved very early on in the process, before there are any lines drawn on the map, all the way to when we have construction and operations.
All right, thank you. The next, oh, I'm sorry.
No, I was just saying I don't have my webcam on, so I can't. Might be hard for you to tell if I'm not done answering the question.
All right, so the next question is, do you know of any upcoming policies and legislation designed to offer better monitoring, mitigation, and protection of marine biodiversity as it relates to offshore wind?
So being in the executive branch of the federal government and being a scientist and not in our legislative affairs shop, I'm doomed to answer this question effectively from your standpoint or my standpoint. I know there is interest in addressing many of the issues of offshore wind energy. There are many state policies that are in place. Some of the issues with those state policies are the fact that they're state policies and they may incorporate areas in federal waters, but all of these resources are transboundary in nature. So that does provide some opportunities to work together and to identify common issues to address. But from a federal standpoint and a legislative standpoint, I do know that, like I said, and I am able to say that the President's FY22 budget has included a substantial increase. I would say a substantial, anything is substantial because up until now, NOAA Fisheries has not, this is a new demand of our expertise and time. We haven't had an offshore wind program. All the people that are working offshore wind have been working on other parts of our mission. So we've been diverting resources, but we've been really fortunate in the President's budget request to understand the importance of these consultations. And so that is thing I am aware in terms of the budget appropriations process, the funds requested for us to work on science and supporting the regulatory process. I'm not aware of any monitoring other than some policies that individual states have provided. But I will say that project by project monitoring, while they may have some excellent monitoring of an individual project, really needs to be done in a consistent and integrated fashion so that we are able to utilize the data and also reflects the cumulative impacts that are happening, not just at a project site, but across multiple projects.
Thank you so much. And that is going to be our last question for today. I just want to be mindful of the time. We did get a question asking whether this recording will be shared, and it will be on the NOAA Central Library YouTube channel. Usually we get those up within 24 hours, and you'll be able to find that. There is a link in the chat that you have access to that has all of the seminars in the EBM-EBFM series on our playlist there that you can access. So if we did not get to your question, those will be forwarded to the speaker and he can follow up with you after he receives those. So I just want to say thank you to our speaker. Thank you all for joining us. After this presentation ends, you will see a survey. If you could take the time to fill that out, we do use those surveys to improve marketing our library seminar service and to inform future seminar topics. So thank you all again for joining us and have a great rest of your day.
Thank you very much, Andy, for all your efforts on this great presentation. Thank you, everyone.
Thank you, everybody.